We need to decarbonize our society, like right now. There are many headwinds that will make that process more difficult than it already needs to be, not the least of which is people who don't understand climate science and those who stand to lose money in a post-fossil fuel world. So it's important that those of us that do understand the challenge at hand make intelligent choices about how we're going to solve this problem. Specifically, how are we going to change the ways that we generate electricity from the atmosphere-degrading fossil-fueled system we have now to something more sustainable? Nuclear energy has come back into the public zeitgeist as one possible way to decarbonize our electric grid. Its proponents rightly point out that fission plants have an exceptionally good record when it comes to both safety and carbon emissions. Historically, fission plants have been the largest producer of low-carbon energy. The electricity provided between 1971 and 2018 by nuclear plants would have released 63 gigatons of carbon dioxide into the atmosphere if it had been generated using fossil fuels. That's about 2 years' worth of energy-related emissions. In a vacuum, those figures would suggest that we should go all in on nuclear power. After all, why mess around with renewables when we already have a proven method of low-carbon energy production? To many, nuclear power is a uranium bullet to kill climate change dead once and for all. We just have to be brave enough to pull the trigger. However, as much as I would genuinely like that to be true, it's a viewpoint that doesn't address the real issues that have held back the nuclear industry from cornering the energy market. It's not hard to understand the point of view of nuclear engineers and activists. Many of them have devoted the better parts of their lives to understanding and operating nuclear plants, and hearing that their industry is in trouble isn't comforting. Also, their opposition has historically been unscientific, bad faith arguments that fossil fuel propagandists have been only too happy to support. Those arguments are mostly NIMBYs fears about completely unrealistic meltdown scenarios and hand-wringing about where to put nuclear waste while they inhale fossil fuel waste. Proponents of nuclear power know that those are engineering problems with engineering solutions that have largely been solved. And that used to be my point of view, that the reason that we aren't using nuclear power more is because of uninformed people being fooled by the fossil fuel industry. But as I learned more in university and on my own time, my opinion changed. Because the problem with decarbonizing our energy systems using nuclear power isn't a political or engineering problem. It's an economic problem. So what do I mean when I say there's an economic problem to mitigating climate change with nuclear energy? This brings us to the central point of this video, that we need to decarbonize, but have a limited amount of time and resources available to do so. This argument is best stated by the 2019 World Nuclear Industry Status Report, which is linked below along with my other sources, and I recommend you read it since it's a comprehensive publication made by real professionals and not just an underemployed college graduate trying to build his brand. I would have used the 2020 issue, but there was some other stuff that happened in 2020 that year's report had to focus on. To quote the central point of the 2019 report, to protect the climate, we must abate the most carbon at the least cost and in the least time. So we must pay attention to carbon, cost, and time, and not to carbon alone. To put it simply, building out nuclear capacity is a very slow process. It takes 5 to 17 years longer to build a utility-scale nuclear plant than to deploy a renewable facility of the same nameplate generating capacity. Nuclear advocates will point out that the long construction times are partly due to strict safety regulations on the industry. But rapid expansion at the cost of an eroded safety culture has been the cause of a great deal of tragedy both inside and outside the nuclear industry. Even minor incidents in the industry in the past have had drastic impacts on public opinion, and an accident could derail an effort to decarbonize through nuclear power. In addition, a renewable facility can begin operating as soon as its grid tie-in is complete while it builds out more capacity, while a nuclear plant can't operate until it's 100% complete. Half a wind farm is half a wind farm, but half a reactor is 0 reactors. The more gradual increase will also make it easier for grid controllers and utilities to adapt our existing infrastructure to current needs, and will start displacing fossil fuels out of our energy portfolios sooner. We are deep in crunch time to decarbonize before we start to trigger feedback loops that will cause runaway climate change that we won't be able to stop. We have 1, maybe 2 decades to decide the fate of our global society. So it's important that every engineering and construction man-hour we have available is well spent. Speaking of spending, the monetary costs of nuclear energy don't favor it as a solution to climate change either. The way that economists and engineers compare the price of different energy sources is by measuring their levelized costs. Levelized cost of energy, or LCO, is determined by comparing the price of building, maintaining, operating, and fueling a power plant with the total amount of energy it will generate over its lifetime. As of 2020, the ELCO of nuclear energy in the United States ranges between $129 and $198 per megawatt hour, compared to $26 to $54 for the same amount of wind capacity and $29 to $42 for solar. Remember, this is cost over the whole life cycle of the plant, so maintenance downtime and intermittency is already factored in for those numbers. And we'll talk about renewables and intermittency at another time, but this video is about nuclear energy. Finally, for comparison, a combined cycle gas plant costs between $44 and $73 per megawatt hour, and coal can go for anywhere between $65 and $159 per megawatt hour, depending on what kind of scrubbers they use. Energy investors and utilities use these figures to determine what kind of facilities they're going to build to meet our growing energy needs and replace older power plants. By and large, energy investors don't care about the politics of nuclear power or decarbonization, only what's going to be the best choice for their business model. And when you step out of the conceptual headspace of economists and into the real world, the numbers agree with what's happening on the ground. Between 2019 and 2022, 45 gigawatts of renewable energy are slated to come online in the United States, compared with a net retirement of 7 gigawatts of nuclear capacity. And for those keeping score at home, also a net retirement of 17 gigawatts of coal power. Go team. This kind of momentum must be considered when we think about how we want our energy policies to look. The supply chains already exist for rapid expansion of renewable energy, while the United States' second largest reactor manufacturer, Westinghouse, declared bankruptcy in 2017 due to delayed nuclear projects. Global trends reflect the uncertainty of the future of nuclear energy as well. Out of the 54 nuclear plants under construction worldwide, all but one will either be government-owned or operate with price controls in place. When taking all of this into account, economists have called into question what role nuclear power has in the energy transition. A 2013 study found that there is little data on contemporary construction costs for nuclear plants in the US due to a dearth of projects since the 1990s, and that new plants would only be economical with a speculative future carbon tax and construction costs overrun of no greater than 15%, compared to the historic average of 300%. The long-term cost trends also favor renewables. Between 2009 and 2018, utility-scale solar costs dropped by 88%, and wind came down 69%, while costs associated with nuclear plants rose by 23% over the same time frame. Another factor to consider is that there are geographic constraints on where nuclear plants can or should be built, as there are with any energy source. A map of where nuclear plants are located in the United States shows a clear east-west divide. Part of that can be explained by population, but it also reflects the difference in the availability of reliable water supplies. A common refrain of nuclear advocates is to point out that what's coming out of the cooling tower isn't smoke, it's steam, which is true. But that water had to come from somewhere, usually a river located adjacent to the plant. Nuclear plants aren't unique in this respect. All thermal energy plants require a steady supply of water to both spin their turbines and cool equipment, and all use a similar amount of water to generate a given amount of electricity. As reliable fresh water supplies become more restricted due to climate change, suitable sites for thermal power plants will only become more scarce. And just as physical geography places constraints on what energy is produced where, the world's political geography must also be considered. Often the online discourse around nuclear energy is focused on the United States and the rest of the global north. This makes sense, as conversations on the English-speaking internet will naturally be dominated by the largest player in that space. However, finding an equitable solution to climate change cannot be done without considering the energy needs of the global south. Most of the fastest growing countries in the world are in the global south, countries that are also transitioning towards more energy-intensive industrialized economies. The fuel demand from a global adoption of nuclear energy would necessitate the usage of fast breeder reactors, which would produce weapons-grade plutonium-239 along with reactor fuel. The limitations on weapons proliferation with current technology are only political, not technical. To me, it seems like a fatally bad idea to add more nuclear-armed states to a world where militant authoritarianism seems to be on the rise in my own country and abroad. Historically, governments haven't used nuclear weapons because of the risk that retaliation would render their nations uninhabitable. But if the environment and ecosystem services of a nation degrade to the point where their government's existence is threatened, the incentive not to use nukes falls away. Climate change breaks mutually assured destruction. That's the big threat, one which warrants its own video in the future, but I digress. Atomic science is fascinating and should be pursued so that nuclear energy might grow to surpass the obstacles I've outlined in this video. Thorium-fueled molten salt plants and small modular reactors show great promise for changing the ways we generate energy in the future. but they aren't here yet. There's no thorium supply chain or SMR manufacturer currently in operation. Renewables are here now, and they're inexpensive enough to price fossil fuels out of the market, and they're only getting cheaper. We have a finite amount of time and resources to address the climate crisis, and political headwinds standing in the way of doing so. And while I don't think nuclear energy is the solution to decarbonization, it's not the problem either. Fossil fuels are. Renewable energy isn't a perfect solution and has its own challenges that will have to be addressed. But right now, it's the best solution we have, and we don't have time to wait for anything better. Thanks for taking the time to watch this video, and I'm sure there will be a lively discussion down in the comments given how divisive this issue is and the stakes involved for all of us. All of the sources cited in this video are listed in the description below, which I encourage you to take a look at if you want to learn more about the subject. That's all for now. Subscribe if you want to be notified for future videos, or don't. Clicking on the video in the recommended tab also boosts the algorithm, so, just find your way here the way you're going to find your way here.